Have you ever found yourself staring up at the night sky or maybe just uh, pondering a simple apple falling from a tree and wondered, why? Why are the laws of physics the way they are?
Hmm.
Why does our universe have these specific fundamental constants it does? The speed of light, Planck's constant, the gravitational constant.
Right.
For centuries, we've pretty much taken these as given, haven't we? The foundational axioms of reality.
We have. That's absolutely right.
But what if they aren't? What if they're actually derived? What if there's a deeper logic to why reality is structured exactly the way it is?
That's a really profound question. And frankly, it's one that most scientific models, from Newton to Einstein, even modern quantum field theory, they just sort of begin with them.
They start with those assumptions.
Exactly. They assume these laws, constant symmetries, as their primitives, their basic building blocks, without really explaining their fundamental origin. It's like getting this incredible blueprint for a skyscraper. But nobody explains where the steel or the concrete came from or, why those materials were chosen in the first place.
That's a great analogy, yeah. And that's precisely why, in this deep dive, we're going to unpack a truly, audacious idea from a cutting-edge paper. It's titled Primitives of Reality, Field Identity Co-Emergence, and the Foundations of the Coherence Vacuum by Philip Randolph Lillian, published just this August 2025. And this paper proposes this radical, unified framework where all of physics,
All of it.
yeah, from fundamental forces to the very fabric of space-time itself, emerges from just two irreducible primitives. It's like finding the universe's actual DNA, not just describing what it looks like now.
And what's really fascinating, I think, about Lillian's approach is this fundamental shift in thinking.
Yeah.
Instead of, piling on more complexity or adding new particles and forces to explain weird stuff.
Right, the usual approach.
This paper goes in the exact opposite direction.
Yeah.
It asks, what's the absolute minimum, the irreducible set of things from which everything else can be derived? It's a search for ultimate simplicity, really, pushing right down to the absolute beginning.
So get ready for, an intellectual adventure. It's going to challenge your deepest assumptions about reality. This isn't just about, surprising facts. It's about presenting a coherent, mathematically constrained vision of how everything might truly start right from the ground up.
Right.
We're going to dive deep into what these primitives are, how they kind of cascade to create our universe, and even the how we could potentially test it aspect of this profound new theory. It's like a shortcut to understanding the very essence of existence.
Sounds good. Let's do it.
Okay, let's unpack this.
Yeah.
Okay, so if conventional models just assume their starting points, Lillian's paper asks that ultimate question. What is the absolute minimal set of stuff from which everything else in reality could possibly arise? And the answer, which is pretty startling, is just two. Two and only two.
That's really a key takeaway here. These two primitives, they aren't just picked out of a hat. They have to satisfy these incredibly strict criteria: irreducibility and necessity.
Okay, what does that mean exactly? Irreducibility.
Irreducibility means you just can't break them down any further. There's nothing more fundamental underneath them. If you tried, the whole framework just collapses.
Ah, okay. The absolute bedrock.
Exactly. And necessity means you need both of them. Without either one, no structure, no differentiation, nothing we recognize as reality could possibly exist.
Both are essential.
Absolutely. And any other potential primitive you might think of, maybe information or energy or something, the paper argues it can actually be shown to be derived from these two. They really are the foundation.
And the paper uses this really elegant mathematical conceptualization to illustrate them, right? To help us grasp how abstract they are. It talks about the coherence vacuum seed conceptually as 0, 1, and the hypergravity seed as 0, 1. Now, these aren't literal equations you solve, are they? They're more like symbols. Could you unpack what they're trying to convey?
Yeah, they're symbolic, but incredibly powerful. What's insightful is how they capture this idea of self-definition and invariant distinction without needing anything external, no pre-existing magnitude or space.
Okay.
Think of 0, 0, 1. Mathematically, that's often undefined.
Right. Or indeterminate.
But here, it symbolizes this self-defining potential, a field that inherently exists and defines itself without external parameters. It's like the universe's ultimate empty set that, just by its structure, already contains the seed of oneness or existence within itself. It's the potential before anything is
So
actualized.
it's not a void like nothingness, but more like a plenum of pure possibility defining itself into existence.
Precisely. And then you have zero point 0.1.
Yeah.
The factorial of 0 is 1.
Mm-hmm.
Symbolically, this captures the identity element, the start of structure.
How so? Factorial is about permutations, right? Arrangements.
It is. So this represents the fundamental ability to distinguish something from nothing, or 1 from 0, or maybe this from everything else. It's the principle of individuality, of form, the invariance anchor. Again, it arises intrinsically without needing external magnitude. It's the spark of distinction.
Okay, so let's dive deeper into that first primitive,
Okay.
the coherence vacuum seed, or field. The paper calls it the undifferentiated hyperfractal possibility space, containing all potential structure in coherent superposition. My first thought is still, an empty void, but you said it's definitely not that.
Right, that's a really crucial distinction. It's not inert emptiness at all.
So what is it? What does hyperfractal possibility space even mean?
Well, think about a fractal like a coastline. Zoom in, zoom out. You see similar complexity, right?
Yeah, self-similarity at different scales.
Now imagine that self-similarity extending not just in space, but across all possible dimensions, all levels of abstraction that's kind of hyperfractal. It means the fabric of this potentiality is infinitely detailed, infinitely structured, self-similar at every conceptual scale.
Whoa. Okay, infinitely rich in potential. An omnilectic field, what's that?
Omnilectic basically implies it contains all possible logical and relational structures. It's the universal canvas, the underlying medium where every conceivable form of existence could coherently resonate.
The ultimate background.
Yes, but a structured one. And here's where it gets really wild. Its intrinsic eigenvalues are described as forming the DNA of the universe.
The DNA, like the genetic code.
In a sense, yes. Think of eigenvalues like the specific notes a perfect bell can ring or the exact energy levels an electron can have in an atom. They're inherent properties.
Not arbitrary.
Not arbitrary at all. In this case, these eigenvalues are intrinsic spectral modes of this omnilectic field itself. They're hardwired constants. You can't tune them without changing the very identity of the universe. And they determine everything, the allowed gauge symmetries, the fundamental constants, the dimensional structures, how matter and fields couple.
So the universe's fundamental properties aren't just random numbers. They're dictated by these eigenvalues.
That's the idea. You can think of it like boundary conditions in a resonant cavity fixing the possible frequencies. Except here, the cavity isn't external. It's the total hyperfractal geometry of the omnilectic manifold itself.
Ah, okay.
The eigenvalues are the allowed modes of coherence that can emerge. They define the possibilities. So why is the speed of light c? Why does Planck's constant have its value? In this framework, they aren't inputs. They're outputs dictated by the eigenvalue structure of the coherence vacuum.
Outputs derived.
Okay, all right, let's move to the second primitive, the hypergravity seed, or identity. This is defined as the invariance and differentiation principle. It imparts form, persistence, distinction, all within that coherence field. So if the coherence vacuum is this boundless sea of potential, identity sounds like the thing that actually carves out the specific wave, makes something this and not that.
That's a great way to put it. It's the structuring principle. Hypergravity isn't a force like gravity, but a principle that gives dimensionality, curvature, torsion, even chirality handedness to that undifferentiated field. So it gives it shape.
Shape, definition, unique properties. It's what makes something persistent, distinguishable. Without identity, you just have that formless ocean of potential. No boundaries, no coherence, no persistence, just unstructured possibility.
Like a thought that never quite forms.
Exactly. Identity makes distinctions possible. It allows for one thing to be seen as separate from another thing. It's the very essence of individuation, of form, of whatness and awareness.
So without identity, the universe would just be this blurry, undifferentiated soup. Nothing recognizable could form.
Pretty much. Identity provides the punctuation marks in the cosmic sentence. It creates the stable patterns, the this is distinct from that, which allows any kind of structural measurement to happen. #TAG-JD. The crucial concept of co-emergence and irreducibility.
Okay, so we have these two incredibly fundamental primitives. Field, the potentiality, and identity, the distinction. But here's where it gets really, really interesting. The paper insists they're co-emergent.
Yes, this is absolutely critical.
Meaning neither can exist without the other, and you need both for anything to emerge at all. It sounds like a very elegant way to avoid an infinite regress, like asking which came first.
It is elegant, and it's logically necessary within the framework. If one came first, you'd hit a paradox immediately.
How so?
Well, imagine pure field without identity. It's just this undifferentiated soup. You couldn't even call it field because there's nothing to distinguish it as field.
Right, nothing to compare it to.
And conversely, pure identity without field, that would be a distinction of nothing. A form with no substance to take shape in, it's meaningless.
Ah, I see.
So their simultaneous interdependent co-emergence is the only non-contradictory starting point. It fits perfectly with those 0, 0, 1, and 0, 1 ideas, where one implicitly defines the other from within. They arise together like two sides of the same primordial coin, not one after the other.
Okay, that co-emergence is key. But it raises a big question, one I bet a lot of listeners are thinking, why only 2? Why not 3 primitives? Or 4? Or 10? Why is 2 the magic number here?
That's a fundamental challenge for any theory aiming this deep. The paper argues that if you tried to introduce a third candidate primitive, it would inevitably fall into one of 3 categories, meaning it wouldn't be truly primitive.
Okay, what are those categories?
First, it might actually be part of the field aspect if it was about potential or relationships, something that could exist or relate. Second, it might be part of the identity aspect if it was about persistence or boundaries or coherence, anything defining a specific thing.
So it gets absorbed into one of the 2 existing ones.
Right. Or third, and this is maybe the most common case, it would already be a derivative. It would require both field and identity interacting to even exist.
Ah, so things we think are fundamental now.
Exactly. Things like time, space, energy, information, even concepts like symmetry or asymmetry. This framework argues they all emerge after field and identity have co-emerged and started interacting. They aren't part of the initial irreducible set.
So the moment field and identity pop into existence together, this incredible cascade starts, beginning with the distinguishable fields. This really is the absolute genesis point.
The spark from which everything else unfolds.
Yes. So once these 2 irreducible primitives, field and identity, co-emerge, what's the very first thing that happens? How does reality start to actually take shape? The paper talks about something called the holectic layer, described as the first reduction stage, where field and identity interact, moving from pure potential towards the first categories of differentiated fields. The moment pure potential gets relationally structured.
This is a really critical transition point, like a kind of cosmic crystallization start. At this holectic stage, identity begins to, let's say, modulate the coherence vacuum.
Modulate? Like impress a pattern on it?
Sort of. It leads to what the paper calls distinguishable loci of coherence. Think of them as separable, distinct substructures starting to form within that big omnilectic continuum. Now, importantly, this isn't yet a full collapse into discrete particles or anything rigid like that. It's more like the pure field, now touched by identity, starts showing internal differentiation, like ripples forming on a perfectly still pond. The very first hint of organization.
And these coherence zones, these ripples, they naturally differentiate into distinct categories of fields. The paper mentions metric-like fields.
Right, the scaffolding for spacetime, perhaps.
Gauge-like field.
Frameworks for interactions, like the fundamental forces.
And scalar-like fields.
Which might act as uniform backdrops, maybe related to things like mass or the Higgs field.
Okay, and this ties into a meta-holographic interpretation. That sounds fascinating.
It's a powerful conceptual model, yeah. Think of the coherence field, that undifferentiated potential, as the reference plate, like a blank holographic film holding all the possibilities.
Got it.
Identity then acts as the structuring interference pattern. It's what defines and imprints the holographic projection of reality onto that plate. So the hololectic layer is essentially the entire set of possible meta-holograms that can arise from that initial field identity interaction. Every fundamental field we know in physics, gravity, electromagnetism, etc., is basically one of these initial holographic modes starting to take a specific form. It's the universe's first set of defined relationships.
So the hololectic layer is where these basic field categories form. But how does the universe get its specific properties, its precise constant speed of light, Planck's constant, all that? The paper connects this directly back to the eigenvalues of the coherence vacuum.
Yes, those intrinsic spectral modes we talked about.
Described as hardwired constants. So fundamental you can't change them without changing the universe itself.
Yeah.
How do these eigenvalues act as the ultimate blueprint?
This is really foundational. These eigenvalues, the seti, aren't just numbers. They are the fundamental notes the universe is allowed to play. They are the DNA of the universe in the deepest sense. They define the allowable modes of emergence. So, for example, they dictate the precise characteristics of the allowed gauge groups, why we have SU3 for the strong force, SU2 for the weak, U1 for electromagnetism, in the standard model.
They determine the symmetries.
Exactly. They literally fixed the fundamental constants, the fine structure constant determining EM strength, the Planck ratios linking quantum mechanics and gravity. They constrain the particle spectra, why these particles exist with these masses and spins. They dictate interaction strengths. They even determine the geometric layering, how our observable dimensions emerge through successive hyperfractal steps, like an unfolding from higher dimensional potential.
So if you could theoretically calculate the eigenvalues of the true coherence vacuum operator, you could predict all of physics just by ordering them by energy or something.
That's the staggering implication, yes. If the analytic mathematics yields the right operator, solving its eigenproblem and maybe ordering the eigenvalues by some threshold projection energy could map these eigenmodes directly to physical phenomena.
Like how?
Well, the lowest order eigenvalues might map directly to the properties of spacetime itself, its dimensionality, its basic metrics. Mid-order eigenvalues could correspond to the quantum fields and forces we know. And progressively higher-order eigenvalues might give rise to more complex structures, atoms, molecules, chemistry, biology, maybe even consciousness itself.
Wow.
It implies that all of physics, the entire structure of reality, is derivable from this underlying eigenvalue structure. What we see as constants are not arbitrary inputs we just measure.
They're outputs.
They're inherent outputs of this deeper spectral structure. And the laws of physics aren't external rules, but just the specific projection rules describing how these omnilectic modes manifest in our observable reality. It's a self-defining, self-constructing universe.
Okay, the eigenvalues set the blueprint. But how does this vast potential actually become, well, the concrete physical reality we see? The paper talks about coherence gradients in the vacuum crossing specific eigenvalue thresholds, like reality snapping into focus in stages, a phase cascade.
That's a great way to visualize it, like walking down a staircase of increasing definition and structure. Imagine starting in that state of pure, undifferentiated potential, everything in superposition.
Okay, pure possibility.
Below threshold, that's where you are. Pure omnilectic potential. Nothing's really projected into dimensional reality yet.
Right.
At threshold. Then, as some coherence gradient builds and crosses a specific eigenvalue threshold, bang, you get symmetry reduction events. This is where things like gauge fields, the space-time metric, basic quantum fields start to appear. It's the birth of distinct physical categories, a kind of collapse of superposition into a more defined state.
The first structures appear.
Exactly.
Yeah.
Above threshold. Crossing further thresholds leads to this cascade of increasing complexity and reduction. This is where you get fermionic matter actual particles, the atomic structure, the amazing complexity of chemistry, the organization of biology, perhaps even mind. Each step is a further crystallization of potential into observable interacting form, all driven by the constraints set by those coherence vacuum eigenvalues.
So this framework fundamentally changes the game. Instead of just postulating constants and laws, here they are, because that's how it is, it offers a derivable pathway.
Precise.
It's not just describing how things are, but explaining why they must be this way, all emerging from just two fundamental primitives. That feels like a huge leap from just accepting the laws as given.
It's a fundamental shift from description to derivation. It suggests the laws of nature are the functional forms, the specific relationships that result from these coherence eigenvalue signatures being projected and actualized via the principle of identity. It implies a deeply interconnected, self-consistent universe from top to bottom.
Now, this whole framework isn't just about the two primitives. It seems to have this really beautiful layered structure, an ontology, right? Organizing reality into levels of increasing complexity, all built on that foundation.
That's right, a tiered ontology.
So tier one is our irreducible pair. Field, the pure symmetry carrier, the potential, and identity, the asymmetry anchor, the distinction maker, the absolute basis, the sort of truth values of coherence logic.
Exactly. But then you might wonder, how do you get from those incredibly abstract primitives to, say, the complex math of physics? It seems like a big jump.
Yeah, it does.
That's why the paper introduces this crucial intermediate class, Tier 1.5. It calls them compound or protostructures.
Okay, not new primitives.
No, definitely not. They're the very first dynamic couplings of field and identity. They define the most fundamental modes of interaction. They bridge that gap, providing the basic rules for how the primitives start interacting meaningfully.
Can you give some examples? What are these protostructures like?
Well, they include concepts like the symmetry-asymmetry operator that describes how field and identity modulate each other, creating fundamental resonance. Then there's a phase modulation operator, which encodes the very beginnings of time, of ordering effects how one state leads to another. And a scale cohesion operator relating to spatial invariance and scaling, making sure relationships hold across different magnitudes.
Ah,
These protostructures are vital. They encode things like the conservation of coherence and define how the raw field identity relationship gets organized into stable, definable modes. Without this middle layer, it would be hard to see how you get a smooth, derivable path to structured geometry or numerical descriptions of reality. They're like the initial grammar of the universe.
that makes a lot of sense. And then building on that grammar at tier 2, we get the first fully systemic mathematical physical architectures, FCHP and NFNs, Finsler coherence, hyperfractal phase space, and Noetherian Finsler numbers. These sound like the operational frameworks.
They are. They operate above that protostructure layer.
Let's dig into NFNs first. The paper defines them as this four-tuple parameterization, NFSAS, and this tuple precisely encodes things like discrete symmetry biases, resonant states, scale invariance, all within the identity configuration. So this is where identity starts to get really specific, like giving it coordinates.
In a way, yes. It's giving identity a specific signature. And the field identity assignments for each component are very revealing about how they're intertwined.
Okay, break it down for us.
Symmetry.
Here, the field component F is maximal, like F1, and the identity component I is minimal, IOBO. This represents the pure coherence vacuum state unmodulated potential, all symmetries intact. Pure field.
Got it.
Asymmetry resonance. This is the inverse, F0, I1. This signifies pure individuated structure, the pure hypergravity identity seed. Maximum distinction, pure form, no blending from the field. Pure identity.
Okay.
Phipi.
Fis.
Yeah.
This is where it gets dynamic. Both F and I are between 0 and 1. This means field and identity are co-modulating, interacting. This produces dynamic states, oscillations, wave coherence, coupling modes. This is the realm of change, where field expresses through identity's form and identity shapes the field's potential, like a wave.
The dance between them.
Yeah,
And kappa.
Scale. Scale.
Mm-hmm.
Here, F is proportional to I and vice versa. This signifies unified invariance across magnitudes. Self-similarity from quantum to cosmic scales, preserving relationships. It suggests the same fundamental dynamics play out regardless of size.
So those pure states, F1, I0, and F0, I is 1. Can we actually find those in reality, or are they just theoretical limits?
That's an excellent clarification. The paper is clear. They are idealized asymptotes, like
Mhm.
mathematical poles you can approach but never actually reach.
Ah, okay.
In any physically realizable state, field and identity are never completely separate. They're always co-modulated to some degree. All physical states exist somewhere within that manifold, in a resonance-ordered continuum. You never get pure potential without a hint of form, or pure form without the medium of potential. They're always intertwined.
Then we have FCHP, Finsler coherence hyperfractal phase space. That's quite a name. It's defined as a structured geometry that already assumes field and identity have interacted enough to create a phase space topology. So it's the mathematical map, the manifold, representing the coherence vacuum, but now with these embedded hyperfractal coordinates. How should we picture this FCHP? Is it like a map of all possible states?
That's a pretty good way to think about it, yeah. It's the natural geometric outcome where fields get embedded within identity space. It provides the structure needed for anything to be somewhere or be something specific.
Okay.
Mathematically, it's described using some advanced concepts like a growth index fibration. But let's try an analogy. Imagine a stack of incredibly detailed maps.
Right.
The base map represents identity space. It defines all possible locations or specific identities something could have. Then each map above it, called a fiber, represents the space of all possible coherence field configurations that could exist at that specific identity.
Ah, so identity provides the coordinates, the scaffolding.
Exactly. And the coherence field then fills in the details, the dynamics within that structure. It's this multi-layered, deeply interconnected space where every single point describes a unique configuration of both field and identity.
That map analogy helps a lot. So it's not flat, it's deeply layered.
Yeah.
And how do FCHP and NFNs connect? Do they work together?
Oh, absolutely. They're deeply connected. That NFN4 tuple we just discussed, those parameters can actually be represented as specific coordinates or points within this FCHP manifold.
I see.
This allows for what mathematicians call a functor mapping between NFN tuples and specific categories of field identity interactions. So you can think of the NFN parameters as defining particular locations or states within the FCHP geometry. Each location corresponds to a specific physical configuration or interaction. SCHP is the stage, NFNs describe the actor's positions and movements.
Okay, so this whole structure, from the two primitives right up through FCHP and NFNs, it really seems to provide this profound step-by-step map. From the generation of reality to these corresponding layers of being, these ontological layers, it's a unified picture of how everything comes into being.
Yes, the mapping is very explicit in the paper, and it really does tie everything together into a coherence story.
So starting at the base.
Coherence, the most fundamental layer. This maps to analytic invariance. That's the pure, undivided potential, the universal coherence field before any reduction. No topology, no geometry yet. Infinite potential, unbroken symmetry, like a perfect mirror, topology. Building on that, this maps to the holelectic field layer. Now, connectivity emerges, but without a metric yet. It's the web of possible relations forming what's linked to what, but not how far apart. Fields and networks start taking shape, like an invisible scaffold, the universe's fundamental relationship network.
Getting more structured?
Then geometry. This aligns with the relational layer. Now, metrics, curvature, proportionality arise. Interactions get quantitative properties, direction, magnitude. This enables waveforms, harmonics, what we perceive as space-time behaviors, distances, angles, shapes gain meaning.
Measurable dimensions.
Exactly. And finally, form. This maps to the derived layer. These are the actualized manifestations, the concrete patterns, structures, functions we observe. Matter, galaxies, stars, information, complex systems, stable arrangements in time and space, chemistry, biology. This is our everyday reality, the end result of the whole cascade.
Wow. So from pure undivided potential right through to the complex reality we see, it's a logical, derivable cascade, charting the journey from nothing to everything in a fundamentally new way, a complete vision of reality's genesis.
That's the claim, yes, a comprehensive, derivable ontology.
Now, if everything truly emerges from just field and identity, what does that mean for the physics we already know so well, like Maxwell's equations for electromagnetism or Einstein's field equations for gravity? The core claim here is, well, it's revolutionary.
It really is.
No field equation. Maxwell, Yang, Mills, Einstein is fundamental. They're all described as differentiated forms that emerge from the field and identity interaction. They're outputs, not inputs.
This is a major departure, isn't it? Conventional physics essentially postulates these equations as the starting point, as given laws.
Right.
But in this framework, they aren't primitive. They're specific, observable consequences of the underlying coherence identity dynamics playing out. What we call laws of physics are really just the projection rules from that deeper omnilectic manifold into our observable reality. They describe how the fundamental interactions manifest under certain conditions.
And the paper suggests that small tweaks in the underlying field and identity configuration can lead to completely different kinds of physics.
Precisely. For instance, the paper suggests that having the same field but a different identity configuration could be what leads to the different fundamental forces. Maybe electromagnetism arises from one identity configuration, the strong force from another, gravity from yet another.
Differentiating the forces.
Potentially, yes. And conversely, if you have the same identity, but different field modulations, that could explain phenomena like phase transitions, water turning to ice, for example, or shifts in coupling constants, the strengths of interactions changing under different conditions.
So mathematically, a field equation isn't fundamental. It's like some kind of operation applied to field and identity.
Kind of. It's represented as a differentiation process acting on the field and an identity which itself depends on a specific eigenvalue or category from those deeper layers. Field equation, a D, F, I, E, N. It's derived, not assumed.
Okay, so this isn't just describing reality differently. It's trying to explain why the forces and laws we know exist in the first place.
Exactly. It's aiming for the why behind the what. Hashtag employment, the vacuum limit of electrodynamics from the framework.
So let's get concrete. Take a really well-established piece of physics. Maxwell's equations for electromagnetism in a vacuum. How does this abstract framework actually derive something so fundamental and tested?
Right. This is a key test case.
The paper goes through this derivation, starting with an effective action from the coherence field, projecting it into space-time using an identity-dependent projector. There's a kinetic kernel. It yields an effective EM action with terms depending on identity.
That sounds quite technical.
Yeah.
Can you walk us through the conceptual steps? How do we get plain old Maxwell out of this?
Sure. To get the standard vacuum Maxwell equations, the ones describing light zipping through empty space, the framework needs to assume a very specific, very simplified condition, what it calls an identity-neutral vacuum.
Identity-neutral, meaning?
Think of it as the most pristine, featureless background state of the identity field. It means three things are assumed to be true. First, the NFN parameters we discussed are constant, unvarying in space or time. Second, there's zero chirality, no intrinsic handedness or twist to the vacuum structure. And third, torsion vanishes, no intrinsic twisting of spacetime itself.
Okay, so a perfectly uniform, unperturbed, untwisted background identity, what happens mathematically under those specific conditions? Well, under those simplifications, that identity-dependent projector, the mathematical tool translating identity into electromagnetic behavior, becomes isotropic.
Right.
It behaves the same in all directions.
Uniform response.
Right. And the inverse kinetic kernel, which sort of describes how energy propagates, simplifies into something called a metric Hodge type operator. Conceptually, this just means the underlying structure translates into electromagnetic effects in the simplest possible way.
Okay. And what does that simplification do to the actual equations that come out?
It leads to two crucial results. First, the constitutive tensor, which describes the electromagnetic properties of the vacuum itself, simplifies down to the familiar Rogusigi. That's just the standard vacuum permittivity tensor, the basic ability of empty space to support EM fields.
The standard vacuum property.
Exactly. Second, and really importantly, the effective current term, Jeff, vanishes. It goes to zero. This means in this idealized neutral state, there are no intrinsic vacuum currents or vacuum charges being generated by the identity field.
No extra sources.
Correct. So when you plug these simplified forms, the standard constitutive tensor and zero effective current back into the framework's general field equations, what pops out? The standard covariant Maxwell equations in vacuum. You had VAFO and FU. The familiar equations describing light in empty space.
Wow.
So it explicitly shows that standard Maxwell is just the neutral, completely unperturbed limit of this deeper, more comprehensive theory.
So the vacuum we normally think of as truly empty space is just one very specific, very simple state of this underlying identity-structured vacuum, like seeing only the calm surface of a deep, complex ocean.
That's a perfect analogy. It's the quiescent baseline. The state where identity isn't actively modulating the field in complex ways that we can see. It's the pure state from which perturbations can then arise.
But the real juice, the real power of this theory seems to be in what happens beyond that neutral vacuum. The framework explains how you can actually perturb this vacuum, introduce variations via identity, using those NFN parameters, the chirality angle, maybe spacetime torsion. This implies the vacuum isn't just a static background at all, is it?
Not at all. When identity deviates from that simple neutral configuration, things get much more interesting. That constitutive tensor, this guy, describing the vacuum's EM response, it's no longer just the simple Chor's term. It gets modified by an extra bit, a det term.
And this captures new effects.
Yes, several crucial, potentially testable effects. First, anisotropy. This can arise from certain NFN components. It means the vacuum might respond differently depending on the orientation of the electromagnetic fields. Light might travel slightly differently depending on its polarization, even in empty space. Second, duality-chirality mixing. This effect is proportional to the sign of that chirality angle. It introduces bianisotropy. This is really exotic. It means electric and magnetic fields can mix and influence each other in ways forbidden in standard vacuum physics.
Like what?
Like vacuum optical activity, the polarization of light could actually rotate as it travels through empty space. Or non-reciprocity light might behave differently going forwards versus backwards through the same region of vacuum.
Whoa, okay. Any others?
And third, scale layer corrections. These come directly from the hyperfractal nature of the coherence vacuum, adding subtle complexities to how it responds at different scales.
Okay, so the vacuum itself can become anisotropic, chiral. And what about that effective current, Jeff, that vanished before? Does that change too?
Yes, and this is a very exciting prediction. In the neutral vacuum, Jeff was zero. But when identity is perturbed, it becomes non-zero.
No.
Meaning it can act as a source of electromagnetic fields, even if there are no ordinary charges or currents like electrons moving around.
Seriously, the vacuum itself generates fields.
That's the implication. This effective source arises from two distinct channels, according to the paper. One is a torsion channel, driven by intrinsic twisting of spacetime. The other is an identity gradient channel, driven by variations in the identity field itself, in space or time.
That's profound. You could generate EM fields just by structuring the vacuum itself.
Potentially, yes. It means the standard Maxwell equations get augmented. The vacuum isn't inert. It behaves like a structured medium because of identity. And if you write the wave equation for light in potential form, it gains specific additional terms.
What do those terms represent physically?
They are the key to experimental tests. There's a term key, which directly encodes that duality and chirality mixing. Seeing effects like vacuum optical activity or non-reciprocity would be evidence for this. Then there's Mirandok, encoding the anisotropic shifts. This could manifest as vacuum birefringence light splitting into different polarizations, traveling at different speeds, like in some crystals, but here happening in empty space.
And the source term?
And CIIUPT, which is that effective source term, the generation of fields directly from torsion and identity gradients, even with no conventional charges.
So we're talking about a vacuum that could potentially twist light, split it, maybe even generate its own fields. And the theory connects specific NFN parameters, N air, N euro, and that chirality angle directly to how strong these effects MKS should be.
Exactly. It demonstrates how the abstract ontology, field, and identity could translate directly into measurable physical effects. That's the crucial bridge from theory to potential observation. What we think of as empty space could actually be this dynamic, active medium structured by identity.
Okay, this isn't just, fascinating math and philosophy. The paper actually lays out concrete, testable ways to potentially validate this whole radical idea.
Which is essential, of course.
The core implication, the hypothesis to test, is this. The vacuum isn't inert. It's an identity-structured medium. And crucially, it can be modulated and maybe even generate fields itself through things like identity gradients and torsion.
That's the crux of it. It's a huge claim, but potentially testable.
If true, it would completely revolutionize physics.
Absolutely. If the vacuum really is this dynamic, structured medium, we should be able to poke it, interact with it in novel ways, and see phenomena that standard physics just can't explain. It opens up a whole new experimental frontier.
And the paper proposes a specific, really fascinating experimental concept, the torsion cavity experiment. The main goal sounds like trying to measure a non-Faraday-induced flux.
Right.
Meaning a magnetic flux that is not created by a changing magnetic field in the usual way, but one that's directly proportional to something called a resonance differential, which is itself driven by NFN-coded torsion.
Okay, that's a mouthful. Can you break down the core ideas here?
Let's try and simplify this ambitious concept.
Yep.
The experiment basically aims to detect incredibly subtle electromagnetic effects that originate directly from the structured vacuum itself, not from conventional sources. The key players are
the coherence vacuum, VAB, that's the fundamental field we're trying to probe, represented mathematically on that FCHP manifold, the NFN 4-tuple M. These parameters are like the control knobs. They're designed to let us impose specific symmetry biases and apply a localized torsion drive onto the vacuum, manipulating its identity structure. Torsion, TABC. This is that twisting or spiraling property of spacetime geometry. Here, it's not just geometry, it's a channel for identity to manifest effects. Resonance phase. This is a property of the coherence field. The trick is to create a tiny, precise detuning or difference in this phase between different hyperfractal layers of the vacuum, and this detuning is specifically influenced by the NFNs and torsion.
Okay, so the mechanism is use NFNs to drive torsion, which affects this coherence phase difference. How does that tiny phase difference become something we could actually measure, like a magnetic flux?
Right, that's the key translation. The idea is an NFN-driven torsion operator is defined, making torsion proportional to a phase gradient in the vacuum. By carefully detuning two nested layers of the FCHP structure, like two cosmic maps slightly out of sync, you create this resonance differential. Torsion essentially pumps a kind of phase gradient pressure into the vacuum.
Okay.
This subtle, structured coherence perturbation is then projected onto the measurable electromagnetic sector using a special mathematical projector. And the derived Maxwell equations for this structured vacuum show that this torsion-modulated coherence should manifest as an effective drive current GEF, and that current is what would generate the measurable magnetic flux.
That is incredibly intricate. What would a real device even look like? What kind of engineering are we talking about?
Conceptually, it's right at the edge, maybe beyond current technology. It's a huge challenge. First, a torsion cavity. Imagine concentric toroidal rings or helical coils, maybe nested inside each other. They might use counter-rotating fields or specific material patterns to impose boundary conditions, an NFN-coded lattice structure designed to induce controlled chirality or handedness into the vacuum within the cavity.
Okay.
They'd likely target microwave frequencies, say 1000 megahertz, need incredibly high Q factors, quality factors, meaning very low energy loss, maybe over a million, and operate at cryogenic temperatures below 10 Kelvin, using superconducting materials, SRF or HTS, to minimize noise and loss.
Super cool, super precise. What else?
A resonance differential drive. An active system to precisely lock and maintain that tiny frequency detuning between two resonant modes of the cavity. A bivector coupler metamaterial. This is crucial. A specially engineered material, likely chiral and anisotropic itself. Its job is to act as that projection operator, funneling the subtle vacuum coherent structure into a measurable electromagnetic signal. It's the translator. An extraction loop. Probably a SQUID superconducting quantum interference device, because they are the most sensitive magnetic flux detectors known. Connected to a cryogenic system with active feedback to keep Ga out right at the predicted resonant vacuum threshold where the effects should be strongest.
That sounds astronomically difficult. What would a more realistic first step look like? A minimal experiment, maybe a level 7 prototype path?
A pragmatic first attempt might be a tabletop torsion cavity, maybe 2 detuned helical resonators inside a superconducting shield or torus. You'd use a SQUID to measure any induced magnetic flux with extreme sensitivity.
And what would you do?
You'd carefully sweep the detuning frequency between the two resonators. You'd also physically vary the NFN lattice angles, maybe by rotating components or changing field patterns. The absolute key thing you'd be looking for is non-Faraday induction.
Explain that again, non-Faraday.
Meaning, you detect a magnetic flux signal that is clearly proportional to that phase gradient pressure, but not proportional to the rate of change of any conventional magnetic field. Proving the signal isn't just standard electromagnetic induction is the critical distinction. That would be the smoking gun.
And what other signatures would really point towards this theory being right?
There were several key things you'd look for, things that standard physics would struggle to explain. First, excess DC flux. A steady magnetic flux appearing only when the cavity is active and tuned, significantly above noise and any possible leakage from outside shields. Second, a phase-locked noise floor dip. Right at the predicted resonant frequency, the coherence line where is maximized, you might see the background noise level decrease in a specific way, maybe indicating energy being coherently organized or drawing from the vacuum structure. Third, and maybe the most compelling, reversible effects with lattice chirality inversion. If you physically reverse the handedness or twist of the NFN-coded lattice in the cavity, the sign or direction of the measured flux should precisely flip.
Why is that so important?
Because a fundamental reversal of a vacuum effect based purely on geometric chirality, without involving particle interactions or high energies, is generally considered impossible in mainstream physics. Seeing that clean reversal would be incredibly strong evidence for this identity-structured vacuum.
That's amazingly specific. And the paper doesn't stop there. It actually predicts how the SQUID flux should behave, quantifying the effects. It uses this projector thing, MAN, which has components for anisotropic gain, R, and electric magnetic coupling, C, depending on NFNs and that chirality angle here.
Yes, the predicted scaling laws are quite detailed, offering a clear roadmap for experimentalists. The paper gives an explicit expression for the expected SQUID flux, as function of the NFN parameters, the chirality angle, and components representing the underlying coherence field.
So what are the key predictions?
Regarding sensitivity to chirality, it predicts a response that's linear in the angle when AIK is small, near zero. Twist the lattice a little, the signal increases linearly. And crucially, it predicts a clean sign flip if you reverse the twist, goes to day. That's a very distinct signature of chirality influencing the vacuum. Regarding sensitivity to NFN components, the N and M parameters are predicted primarily to affect the baseline magnetic scaling through that R block. This would show up as anisotropic shifts. The overall signal strength might change depending on orientation. Regarding sensitivity to NFN components, the N and AM parameters, however, are predicted to modulate the slope of the electric magnetic coupling via the C block. This effect should vanish when chirality is zero and grow with sin. So these parameters control how strongly E fields generate B fields, and vice versa, in the structured vacuum, especially when chirality is present.
Okay, so by changing the orientation of coils or fields relative to the cavity structure, experimentalists could try to perform separate fits for these parallel versus perpendicular responses and directly measure core parameters of this model, like C and C.
Exactly. They could directly test the mathematical structure predicted by the theory. The paper even describes the expected visual results from sweeping these parameters.
Like what?
You'd expect to see a near-linear plot of flux versus angle, maybe a linear trend for V versus N at zero angle, showing the anisotropy, and a different linear trend for E versus N at a fixed angle, showing the EB coupling effect. Seeing these distinct predicted dependencies would provide strong evidence, moving the framework from pure theory towards observable reality. Hashtag D challenges and failure modes.
Now, with experiments this groundbreaking, pushing the absolute limits, there are always going to be huge challenges, potential pitfalls, ways it could go wrong, or give misleading results. It's important we're upfront about those.
Absolutely. Transparency is crucial here.
What are some of the main hurdles or failure modes a team trying this would face?
Oh, there are many. It's incredibly difficult work. One major concern is always spurious electromagnetic coupling, just stray EM fields from the lab environment, or imperfect shielding, accidentally mimicking the tiny signal you're looking for.
How do you fight that?
Mitigation involves extremely careful design things like orthogonal coil geometry so signals don't crosstalk, and active null channels designed to measure and subtract any known or unwanted background EM signals. Ensuring what's left is truly novel.
Okay, what else?
Another big challenge is mode crowding inside that high Q cavity. You might get too many unwanted resonant modes interfering with the specific one you're trying to probe, potentially leading to what the paper calls coherence collapse, washing out the effect.
So you need to isolate the right mode.
Right. That requires things like carefully placed mode-selective absorbers inside the cavity to damp down unwanted resonances, ensuring you're only sensitive to the desired vacuum coherence mode.
And working at cryo temperatures must be tough.
Definitely. Thermal drift is a constant enemy. Even minuscule temperature fluctuations could shift the cavity dimensions or material properties just enough to break that critical resonance differential lock.
Oh.
Maintaining stability requires advanced cryogenic phase-lock loop systems, maybe active feedback using piezo elements to constantly fine-tune the cavity dimensions. It demands incredible stability over long measurement times.
So yeah, while the theory is incredibly compelling, maybe even beautiful in its structure, the experimental validation is, well, it's extraordinarily demanding, pushing the absolute limits of engineering and measurement.
It absolutely is.
Yeah.
But the potential payoff, discovering something fundamentally new about the vacuum itself,
Is immense. It's the kind of discovery that could rewrite our entire understanding of the universe. So what does this all mean? Where does this leave us, the listeners? We've taken a truly mind-bending journey today, diving deep into this paper by Philip Randolph Lillian. We started right down at the bottom with potentially the most fundamental components of reality, the coherence vacuum seed, representing pure potential, and the hypergravity seed, the principle of distinction and form. We saw how they have to co-emerge and then how they cascade through layers, the holelectric field layer, defined by those intrinsic eigenvalues to produce literally everything we observe, including the laws of physics themselves, which we maybe thought were just arbitrary inputs.
right, seeing them as outputs instead.
We even touched on a concrete, though incredibly challenging experimental idea, that torsion cavity experiment, that could potentially test this, could show us that the vacuum isn't empty, but maybe this dynamic, structured medium actively shaped by identity.
And fundamentally, this framework isn't just offering a new description of reality, it's proposing a derivable reality. It argues that the constants, the laws we thought were just given, are actually necessary outputs of a deeper spectral structure within the coherence vacuum.
A universe with an inherent internal blueprint.
Exactly. Where everything flows logically, maybe even inevitably, from just those two primordial co-emergent seeds. A universe that defines itself from within.
It really makes you wonder, doesn't it? If the vacuum itself isn't empty, but this dynamic, structured medium shaped by identity, what new possibilities could that open up for technology, for understanding consciousness maybe? Could we even theoretically tune reality itself someday? If our universe is like a symphony and its notes and harmonies are dictated by these fundamental eigenvalues, could we ever learn to play new tunes? What stands out to you as the most profound implication if this turns out to be right? A universe where everything derives from just two co-emergent seeds.